while I am playing Warp Ancestor in Unity. Right. What I'm going to do today is focus on the asteroids that are in the game. And the article includes the current models and their links to where they're available on the NASA website. So this again, public domain, as in anyone can use them. Doesn't matter what country, you know. And use them in graphical simulations and imagery and a variety of other types of products. All right. I also published the full list of the whole thing. So all of the objects. It's a poster, so you can download it, and it's about 3 feet by 6 feet. It's a big wall poster, and it's for free, so you can download it from here. And this gives you an idea of the scale of the number of assets I used from NASA that they made over a decade, and it was free this whole time. Free. There you go. All of this for free, and it's like the real location. It's the real scan by the probe or the orbiter that gets sent back and visualized and analyzed and then modeled and so on and so forth. And then it gets made available to the public. But by scale, you can. Anyways. Oh, my face is going haywire. I think it's because of the multiple mod. Okay, so I'm just gonna drop this and you guys can see it anyway. Okay, asteroid hunting. It's asteroids. I don't think the NASA models that I use are any of them are comets. I'm fairly certain that none of them are. But in the game, asteroid and comet is mentioned in the legends, which you can access by L key. And those asteroid and comet icons are singular, so that means it's just one icon for both types. And then if you get there, so we're gonna check this guy. You can realize whether it's a comet or not. You may be able to see the tail better. Okay. The telemetry gets holographically projected above the object. It will always face you, but you have to orient yourself because you're in space, and the axis of that object is independent from your axis. So its north is not your north. End of story. So Geographos. Let's take a look at this guy. Excuse me. Right, so Geographos. If you look at the values that get represented on any object in the solar system in the game, you'll get semi-major axis, so the distance from the sun in the unity scaling that's applied, right? And that fits within the floating point precision scale of the whole system, of the whole ID, the game engine. But you still get a semi-major axis in astronomical units, which is what the real astronomer that's following that trajectory is just an angular type of positioning for the object in its orbit. The orbital period again now is in seconds. It just tells you how many seconds it takes to revolve around the sun. So this guy takes quite a bit. You know, you'd have to spend the whole day basically in game to see it do one revolution. Inclination, longitude of ascending node, these are all things that allow you to track this object via telescope. So you can use this while you look at the stars. And you might bump into something and you're like, whoa, wait a minute, these are the very close, these coordinates. I mean, it's moving. And might be that. You can double check. Use a third source or something besides your telescope and the simulation. Okay, so geograph. Let's take a picture. Let's see what happens. Actually, we're gonna see if we can. We are recording this, so I don't need to re-record Unity. Beneficial to my reiteration process, right? So I already know this works perfectly. So I played the game also for enjoyment, of course. But when you're launching it, it's a lot of marketing, and you have to deal with the other things in the business aspect of it. Wow, this one's a little bit further out there. Oh, it's coming up. Okay, we hit some band here. It's not the Kuiper belt. A lot of this is not identified, so there's a lot of floating, much smaller asteroids out there that could still cause damage. I mean, you're basically talking about possibly a thermonuclear explosion event, right? Just a shock wave from a very large, say, apartment building sized object. I mean, it wouldn't get to fusion, like it would be some weak yield. Say if you had like an apartment size asteroid crash somewhere Midland, like in the middle of a continent, there's lots of people, so it would be like almost like a nuclear event. Okay, is that following that? I'm just trying to get a clearer view. I think it's just too far. No, it's here. I was distracted by the belts, the smaller ones. I mean, in the game, because it's exploration. Oh, is this Mithra or Cleopatra? Let's take it. Ooh, the dog bone one. Which one was the dog? only one. Let's see. Cleopatra, yes. My second guess. So the textures. So again, this is a NASA model. It was smooth, but you can still see polygonal faces, right? So Cleopatra might need an additional pass. Okay. Cool. But the textures are from, let's take a look. Let's first take a look at any textures. Cleopatra, asteroid, texture. Let's just first, what I like to do is just to do a search for the object. And let's see. Okay, yeah, you get the description, Wikipedia, then some actual imagery. But still Wikipedia. There's nothing wrong with Wikipedia if it's sourced. Right, hard to see any kind of texture on it. Alcatron, a free social encyclopedia. Vatican Observatory. Okay, a legitimate source. A legitimate source. I'm sorry, I have a cold, so it is what it is. GPL. So if you look at the JPL texture, which is still decent resolution, right, on their own model. This 5 years ago. Is very close, or again, just because this is in game and you have actual lighting casting from the sun plus lighting from your vehicle, from your spacecraft, right? But the polygonal faces are visible. The polygonal faces are basically just these see these triangular shapes that make up the model being this shape, this 3D shape, which is the asteroid. Okay, so we'll put another pass. Let's try this. So this is all live, like real time in Unity, me working the system I recreate. All right. Just maybe run some progress. Right now we're at 320 some million kilometers away from the Earth. Okay, so let's do this with Cleopatra. Right, so that's too rough, right? So we're gonna, while we're paused, we're gonna go in Blender, import the model, we'll run a pass to run a smooth shading on it, and just save that, re-export to the same FBX, come into the game. It's gonna, behind the scenes, adjust the model, and then we're going to take a look, because it's referencing the mesh, which is referencing the object in the project hierarchy, which means that any changes applied to that object referenced, whether it's a copy or prefab or not, will apply live, like real time. So you're basically also building and not separating debugging from once you're at a certain level from just playing, right? So you play and you debug at the same time and you get stuff done faster. Manually sculpted or something. Okay, hold on a second. There we go. Ta-da! I just forgot something. It wasn't a limitation. All right, of course. Obviously. Let's re-export. Problem solved in real time. Cleopatra. Export to FBX. Absolutely. Okay, should have done it. It's updating. Let's take a look first at the mesh level. Fixed. All right. You gotta try everything, right? But I didn't. I mean, I stopped at the second educated guess, which was the correct one. Visiting the next one. So Geographos, Cleopatra, and now we're going to the third one. You know what? I might switch ships. Let's take a look. Let's go a little bit faster. There it is. Oh, I'm having a hard time tracking myself. Just not into the sun. Icarus. Alright, here we go. I forgot I switched back to Warp 1 because it persists which ship you have. So but you gotta let it save once you switch. It saves, auto saves every 60 seconds. You don't have to worry about saving. You know, be cognizant of that. Oh, listen. Go face it. Oh wait, which one is this one? Because it's menu. So people have been talking about this one again. So this was the Osiris Rex sample return mission. Well, the data for it, and now it's turned into Osiris Apex, which is headed towards Geographos. Look at that. So again, this uses the material that Manu is actually known for, the texture, that grainy, craggly surface. Let's check this out quickly. Surface. There we go. So you can look at the images. It's like one big backyard in the desert or something, and it's like some sort of ashy desert. It's full of rocks, and it's like, so that's what it is. And where's this from? Universe magazine. So semi-reputable for accuracy. This one is SciTech, so I follow these guys. This is just a sun-kissed version, but it's the same darker texture like this. And this is also like a smaller scale type of texture that's superimposed at this, representative scale of Bennu here. So there's a dissonance in the topography of the texture, what it looks like, and how it's put onto this egg-shaped, like lemon-shaped asteroid. So, what is this? Blah, blah, blah. Right, our mission. So let's go back, and I need to go back to Cleopatra. Easy there. Okay, let's go back. So I traversed, so it's actually on this side. Let's take a look. I know where I am. I want to look at Geographus and Cleopatra. Most Cleopatra. Just to make sure. I think she was a little bit further. Right, so this guy is Golevka. So again, same kind of thing. The texture is correct. I know that she's accurately represented. So we're gonna just go to Cleopatra.
As you can see on this linear scale here, and consider 0.1 to be 10 to the minus 1, 1 over 10. And then 0.01, which we could, again, if we expand on a linear scale, this single space there into 10 separate units, 0.01 becomes 10 to the minus 2, and so on and so on. This allows us to talk about scales from the very large to the very small in a single graph. It's more than just useful pedagogically, as you, from the point of view of presentation. You'll see it's incredibly important for actually understanding the details of how physical systems work. And we'll talk about that in the next lecture. But I want to use this scale here to try and discuss the physical universe. And in fact, because we're talking about powers of 10, I want to show you the physical universe on scales of meters. And I have down here 10 to the minus 28 meters, all the way up to 10 to the 28 meters, with 1 meter right in the center. Okay? And I want to talk about what we know about the universe on scales not quite this large, but as large as we've ever been able to see, and as small as we've ever been able to see. And that gives us a sense of the universe as we know it, the playing field of physics, if you will. So I want.
Oh, wait a minute. Holy moly. Oh, good. I didn't drift into any unsafe direction and be in trouble. course, the objective is exploration, not to perish. And but that can happen, but only on planets. The spacecraft, they're not weaponized. And it'd be catastrophic to put like prototype weapons for space on the first set of sub-relativistic craft. They would be exploration only and traversal. So that's what it would be. Here we go. Oh yeah. So we're at Cleopatra again. So we're gonna conclude with this. I already knew which one, of course, was not this rendering quite appropriately. So a smooth surface from the player's perspective versus a polygonal surface with triangular faces, a bunch of different triangles, equilateral, isosceles, so like all kinds of triangular shapes. And even there, see at the tail end of it, there's a bit of okay, but this is a satisfying pass, I think, and it looks good enough. Let me adjust the overall material. Why is it? It's extracted. Okay. Smoothness perhaps. Let's look. This looks okay. Minus. Oh, here we go. See that smoothness? What the hell? There we go. Right. It's not buff, It doesn't have a sheen. Okay. So I was already checking that. I don't need to head back and double check. I was already checking it in scene while I pause the scene. This allows me to just not have to foot it back and forth and check the correction. So something like this here, where it's crinkled, either demands resculpting here, or I mean the 3D object is fine, but it's the mapping of the this texture. But this is the correct texture for it, so it's the one we're going to work with. We're not going to change the texture so that it adapts to the model's mapping, just because you get rid of the crinkle or some nonsense like that. We're going to keep the texture of the actual asteroid for authenticity, and that's more important than some kind of visual crinkle. So I mean, in a simulation, of course. All right. So this is okay for now. Doesn't mean I'm done with it, but it's sufficient. Oh. So the problem with this second craft is that its profile makes it less stable, and it's more responsive, especially at these speeds. So you have to kind of slow it down, line up to the overall trajectory. You get fast at this. I'm in mouse mode, like navigational flight mode. Use the mouse to rotate and micro thrust the craft into the direction that you want it to go. So when you hear that ooh, like a electrical hum, it's micro thrusting. It means it's, you know, adjusting you, and that like scales. Say if I slow down, it doesn't need to micro thrust as much. Like say if you're doing bow and stern, and where your micro thrusters are, like if you're strafing, if you're rolling. Right. For this ship, there's two on top. I'm not going to go into that. That's in the engineering of the ship's spacecraft. So again, the rest of them are correct. We're going to just pick another one closer to the sun. Hey, watch that plasma. Can collide with the sun, but its magnetic field is going to just ricochet you right off. Oh yeah, we just passed geographics. It's on the other side. I don't necessarily have a ordered list of them. That list is already in the game, running in the ephemeris. So I don't. I have the list in the article. You can choose to go that route where you follow them from A to Z or something, but you don't have to. I just like to go there. Which one is it? Eventually, you're like, I know which one this is. Just by heart. Vesta. So Vesta, it's almost like a dwarf planet, you know, like it's compressed of a shape enough, and it's bigger. And I think it's just a little bit closer to Earth than Ceres, which is past Mars. Or its orbit goes past Mars at some point. Okay. Right, so I know how to orient myself to find it. So this, again, this texture is actually a really great texture. This one is an example that wraps nicely on the model and it tiles nicely. So it makes it look realistic. It is because it is realistic. Each chip has its own like lighting color. It's got its own reflectors, different colors. So right, this guy has a nice texture that maps nicely without any issues. Looks believable, looks realistic, no crinkles. Everything is nice. I like it. But this is because this is a originally, let me show you. Originally unified model. Let's go to the source. Planetary resources. Easy to find, but buried. If you had to scroll, you have to scroll like all the way to NASA 3D resources, 3D models. So to go all the way here, 25 pages of the results, and then say asteroid, and then you get them. Most of them are sliced, so you have to rebuild it. Sorry, some of them are sliced. So, for example, Vesta actually comes with a nice sculpt. All right. Right. So this is a nice sculpt because it contains like surface details, like little craters and hills, because there are some hills here. So it's nice. And since we're on the page for it, it's the second most massive body in the main asteroid belt, right? And I was discussing how Ceres is not far from it. Only dwarf planet Ceres is more massive in that region of rocky debris between Mars and Jupiter. Right. Cool. All right, so I mean, all of these are, the rest of them are okay. It was just the Cleopatra model that needed to smooth it out. Okay, so that's it for today. I'm going to continue this just on the asteroid side, and then we're going to progress into dwarf planets because there's quite a few.